Today we're going to talk about solving systems of equations, and we're going to do that by graphing today. So as we see right here in number 1, we have two equations. We have to solve it. So it's important to understand what a solution of a system looks like. It's basically where the two equations intersect. And so the solution of that would be either 1, 2, or 0 ordered pairs, depending on what type of equations we're talking about. Sometimes it's actually more than 2. So what I'm going to do is solve each of these for y, since we are going to do it using graphing. In order to look at the graph in the graphing calculator, it has to be set equal to y. So I'm going to solve each of these for y. I'm going to divide every single term by 2 because this can be reduced. This one can actually be reduced as well. This is really x over 3 plus 9 over 3, which is 3. So what I'm going to do is get the graphing calculator. I highly recommend that you do this along with me. So everybody go ahead and open your calculator, go to y equals, and we're going to type in these two equations. Don't forget about the alpha y equals option. So I'm going to put x over 3 plus 3 and negative x minus 1. I'm going to look at the graph, and I think mine is already in the standard window. That's a good place to start, from negative 10 to 10 on both axes. So there's the first equation, there's the second equation, and since these are both linear, then they're only going to have at most one intersection point. Unless they overlap, then it's an infinite amount of points. So this is what I'm looking for right here, this ordered pair. Sometimes you can somewhat tell by looking at the graph. Sometimes you can tell by looking at the table of values. So if I look at the table of values right here, I see that when x is negative 3, the y values are the same in both columns. And so that's going to be our solution. But I do want to show you another way, because sometimes it's not always clear on the table. So I'm going to go to second trace to get into the calculate option. I'm going to go to 5 for intersect. And I'm just going to hit enter 3 times. It'll automatically jump to the second graph, and then it asks for your guess. And so the intersection point is our solution, which we kind of saw by the table already. So it's negative 3, 2. So we're going to go ahead and write that in a solution set. Sometimes there'll be more, but this time we're just writing it as an ordered pair, negative 3, 2. So that's the solution for this. Not a bad idea to double check, but when you check it, you want to check it in both equations to make sure it checks out for both of them. Here's another type of example. And so again, I'm going to solve for y. If we're doing this by graphing, that's really important. Solve this for y. Divide every term by 2. So we have y equals x squared plus 2, which hopefully by now you recognize as a quadratic. And then we have y equals 2x plus 2. So I'm going to go ahead and clear these equations out. And for y1, I'm going to put x squared plus 2. That will give me a parabola. And for y2, I'm going to put 2x plus 2. When you have a parabola and a line, the most that they will intersect are 2 points. They could intersect at 1 point, or they could intersect at 0 points. So I'm going to look at the graph. There's the parabola. There's the line. So it does look like we have 2 intersection points. if you can't tell, then you might want to zoom in. That's always an option by going to zoom. But we can kind of see here that there's the 2 points. So I'm going to use that intersect function, second trace, 5 for intersect, and I'm just going to hit enter 3 times. That's going to bring me to my first intersection point of 0, 2. So that's one of the solutions, 0, 2. And now to find the other intersection point, as a reminder, we have talked about this in class, but let me just show you. I'm going to go to second trace intersect again, and I'm just going to arrow over to the other intersection point before I hit enter 3 times. Go ahead and rewind that and watch it again if you didn't catch that. So my other intersection point is 2, 6. And that's the solution of this particular system. So here's one more for you to try. Good luck. We'll talk about this in class.